how many different ways can we select a president, vice president, and treasurer for our class? Assume there are 30 students. All right, so in this class, if we have three particular positions we need to fill, which is president, vice president, and treasurer, as I've done before, we've got our stick figures of 30 people, okay? And let's say that of all the people, how many people can be president? Well, no one has really been selected for anything, so it sounds like we really have 30 people that can be president. Let's say person B actually was selected as president. Now that person is no longer an item that we can select, a choice that we can select for our next position, which is vice president. Which means if we take one person out, it sounds like we have 29 other people to choose from for vice president. Let's say now, okay, this person has been selected for vice president. How many people do you have to choose from for being treasurer? Well, you now have 28 people for treasurer. Okay, so how many ways can we actually select a president, vice president, and treasurer? Well, you're actually just multiplying these values together. 30 times 29 times 28. Okay, and in doing that, let me get our calculator out. Okay, we get 30 times 29 times 28, 28. And we get a value of 24,360 ways. Okay, now let's take a look at problem number 10. Let's see how this one's different. How many ways can we select 3 people to represent the class on a school committee? Okay, so if we have a school committee, again, instead of drawing stick figures, let me actually think of the people as letters, okay? So let's say we have person A, person B, and person C. So if we have 3 people being able to be selected on a school committee, maybe of the 30 people, maybe A was selected for this spot, and then B was selected for this spot, and then C was selected for this spot. Now they're on a committee. So did it matter that I chose them as ABC? Or maybe I could have had them as CBA. Does that matter? Does putting person C in this position matter if all they're doing is going in a committee? They're actually still in the same committee. Let's say they're actually sitting at a table. This committee of A, B, C, it's the same as a committee with C, B, and A sitting in this position. It's still the same 3 people discussing whatever they're discussing about school-related topics, right? They're just talking. So ABC is really the same as CBA. In fact, there's a number of repetitions going on here. And the way that I would recommend you handle these repetitions is by having some kind of systematic approach. What I mean by that is, let's say I have person A in the beginning. Well, if I stick with person A in the beginning, then that must mean, I could still have the same committee by just swapping B and C, so it really becomes C and B. Now that I have exhausted all the possibilities where A has initially started, then, another type of committee I can have is maybe where B is in the initial spot. And so if B is in the initial spot, I can have A and C. And if B is still in the initial spot, I can have C and A. But again, these repetitions, all these types of ways I'm finding how we can rearrange A, B, and C, it really is the exact same committee, okay? So just realize, all I'm doing here is just creating repetitions. I'm understanding that, as I go through this systematic approach, now I'm putting C in front. CAB is the exact same as ABC. If I have this C here, then I could swap B and A. But again, all of these are the exact same thing. And so for that reason, it looks like I think I've exhausted all the possibilities in which I can have these 3 people, A, B, and C, be on a committee, and yet they're still the exact same committee. It's just repetition. Okay, so I really recommend you do the same thing, where you go through a systematic approach to find all the number of ways in which you actually get the same committee. Now, because we get the same committee, again, you're thinking, okay, in the school committee, we had 30 people to choose from. So in this spot, right here, that first choice, you had 30 people to choose from. You also had 29 people to choose from once you selected that first person in slot A. And then you again had 28 people to choose from in this slot here. However, with all the ways that we can get this committee, you'll notice that there's repetition that has occurred for those 3 individual students 1, 2, 3, 4, 5, 6 times. Basically, you can see here that based on the systematic approach, you have 3 ways to get the same pairs, right? You can see these pairs occurring here because we just swapped B and C. So because you have that repetition, you want to get rid of or divide out the repeats, the pairs, the groups that are repeating. And we had 3 ways of getting those pairs. So you divide it by 3 times 2. So the example that we had earlier, that number gave us 24,360, and you're dividing it by 6 repetitions. And for that, go back to my calculator. We divide that by 6, and we get a value of 4,060 ways. Okay, so we have 4,060 ways to get 3 people on the committee because really the order, in this case, the order does not matter. Order does not matter because ABC is the same as CBA, is the same as BAC. Order does not matter. However, in our first choice, it does matter. If you're president, that is a completely different position than a vice president or treasurer. Each of those positions are unique in their own way. So here, order does matter. Now, the reason why I'm emphasizing these words here, order does matter and order does not matter, you might have heard this before. When we're talking about counting the number of ways in which order matters, what we're talking about here is finding what we call a permutation. A permutation. Okay? And oops, what did I do? Oh no, sorry. Going back. And the way that we can find the number of ways in which the order doesn't matter is called a combination. So this is the difference between a permutation and a combination. Now it turns out that there is a formula you can be using here. If you want to work with permutations, the formula we're working with is an NPR. Okay, and using those NPRs, N is representing the total amount that you have to choose from, and R is actually choosing those number of items. Okay, so the way you use this formula is that if it says NPR there, you would say N factorial over N minus R factorial. Okay, and if you're doing combinations, let me actually highlight this. This is a pretty important formula that you'll want to remember. Okay, but the other formula that you want to use for combinations would now look like NCR, C standing for combination, P standing for permutation. And basically you have seen how combination actually takes what you have seen before in a permutation. So basically it's still seeing the same thing, which is n factorial over n minus r factorial. You're still going to get that 30 times 29 times 28, which had occurred in a permutation. But now what we're doing is dividing it by something else as well, that 3 times 2. Where's that 3 times 2 coming from? You're actually dividing it by what's called the r factorial. Okay? Because remember, that's the number of items you're choosing. You can see you're choosing 3 items here. Okay? All right, so you could use these formulas. Some people are more inclined to just kind of work with formulas, but in my class, I do try to have my students find easier ways of interpreting how you can do permutations and combinations. So here is what I would recommend for you. Okay, so I'm going to choose some easier numbers here. So let's say that I had 7 items to choose from, and I really just want to pick 3 of them. So if I want to do a permutation, so what I'm saying here is a 7p3. Okay, and so if I have 7 items to choose from, and really notice how you're choosing 3, which means I just have 1, 2, 3 things that I need to fill up. And I have a total of 7 items, but since I've exhausted one in the first slot, I now have 6 items here, and I've exhausted that, so now I have 5 items to choose from there. So what I have is 7 times 6 times 5, like that. That's basically how you do a permutation. Let's do another example. If we had, let's say, 5p2, then what this is saying is, okay, I have 5 total items. I need to choose 2, which means, okay, I need 2 items here. And I have 5 to choose from initially. And then I have exhausted one of them, so now I have 4 to choose from in the next one. That's 5 times 4, like that. Okay. Going to some bigger numbers. Let's say we were to do, let's see here, let's do 13p7. Okay. What we're saying here is I have 13 items to choose from. I only want 7 though. So 1, 2, 3, 4, 5, 6, 7. Okay. And then, so if I have 13 total items, I can say 13 times 12 times 11 times 10 times 9 times 8 times 7. And then you just do the calculations and you get your value, just like that. Okay. Now, how does this change if this were a combination? Let's do those as well. I don't seem to have any more space here. So what I will do, you can pause the video if you need to. You can rewind, of course, but I'm just going to erase all this here. I'm going to leave some room for myself to do combinations now. What I'm going to do is I'm going to pick the same exact numbers and show you what a combination would look like. Okay, so over here, let's again have the same values, but this time I'm going to make it a 7c3, a 5c2, and a 13c7. Okay. When it comes to a combination, what I see here is, okay, 7, choose 3. So I'm going to pick 3 things again. So 7 times 6 times 5. And then I'm going to divide that by, see this number here, that 3? Just do its factorial. 3 times 2 times 1. Just like that. That's 7c3. If I wanted to do 5c2, again, I'm thinking of it almost like a permutation. Okay, so I have 2 items to choose from. 1, 2. I start off with 5 times 4. And then because it's a combination, I divide it by, what's this number here? 2 factorial. 2 times 1. Just like that. 13c7 means first, just like a permutation, I have 7 slots to fill. 1, 2, 3, 4, 5, 6, 7. I start off with 13 items initially. I count down 13, 12, 11, 10, 9, 8, 7. And I now divide it because it's a combination. I want to get rid of all the repeats. What repeats are there? It starts off with 7 factorial. So 7, 6, 5, 4, 3, 2, 1. Just like that. Okay. And then you just do the calculation there. Now, a good rule of thumb, I would say, a warning here, is you don't have to type this in your calculator like this. What you can do is you know how to simplify fractions. You've done this in elementary school and middle school. Simplify fractions can really just be saying, okay, what numbers do I see in common, right? I see that there is let's say a 3 and 9. That'll give me a 3 here, right? A 4 and 2 is the same thing as 8, so 4 times 2 cancels out with this 8 here. And so you can just see here, certain numbers can be factored out, and then it'll just make your life a whole lot easier when you simplify. As you can see, I've simplified the entire bottom. They all got canceled out. So now all I have to do is 13 times 2 times 11 times 2 times 3, and then that'll be my answer. That's it. Okay, so that's how I would recommend doing these kind of combinations and permutations as you're doing it by hand. Okay, all right, and I think that'll be it for our lesson today on permutations and combinations.